Start the lecture notes for Chapter 11 on mountain building. Chapter 11 is divided into three sections. Section 1, where mountains form. Section 2, how mountains form. And Section 3, the different types of mountains. In Section 1, we look at where mountains form. In general, the world's mountains lie in belts that follow Earth's plate boundaries. Mountain building occurs along active continental margins. Large amounts of sediment accumulate in the relatively shallow water of passive continental margins. Continental crust on a passive margin is deposited along the coast where an oceanic crust meets a continental crust. Over time, mountains wear away, creating the sediments. Rivers and other agents of erosion carry the sediments to the oceans. These and other sediments are deposited along passive continental margins. Vocabulary for Section 1. A mountain is a large mass of rock that rises a great distance above its base. Continental margin is the underwater part of the continental crust, which includes the continental shelf and the continental slope. In Section 2, we'll take a look at how mountains form. Mountains are made up of rocks that have been deformed under stress. Three types of stress are compression, tension, and shear stress. Compression involves pushing in of the different rock layers. Tension is the stretching of the different rock layers. And shear stress is the sliding past each other at a boundary of the different rock layers. Stresses applied to rocks form folds, faults, and joints. A fold is a crumpling of rocks due to stress. A fault is a break in the lithosphere along which movement has occurred. Normal faults occur where tension pulls the crust apart. This is an example of a normal fault, and again notice that the stress is in opposite directions. The hanging wall falls in relation to the footwall, and the footwall remains where it is. The hanging wall falls in a normal fault. Reverse faults and thrusts are caused by compression. Again, a reverse fault, the easiest way to remember is that you have compression. The hanging wall moves up relative to the footwall in a reverse fault due to compression. Strike-slip faults are associated with shear stress. This is an example of a strike-slip fault where one fault moves in one direction, or one block moves in one direction and the other one moves in the opposite direction. A joint is a break in the bedrock along which no apparent movement has occurred. It's just a crack. An anticline is an upfold in rock layers. A syncline, as the word implies, is a downfold or a sink in the rock layers. A normal fault is a fault in which the hanging wall moves down with respect to the footwall due to a shearing or the rock masses moving in opposite directions. A reverse fault is a fault where the hanging wall moves up with respect to the footwall caused by compression. Those rock blocks are moving towards each other. A thrust fault is a reverse fault in which the fault plane dips 45 degrees or less from the horizontal. A strike-slip fault is a fault where the rocks on opposite sides of the fault plane move horizontally. They're sliding past each other. And a joint is a crack or break in the bedrock along which no movement has occurred. Section 3, the different types of mountains. Mountains can be classified by features that result from forces associated with the plate tectonics. Folded mountains can form when two plates carrying continents collide. The Himalayas are an example of a folded mountain. The Indian and the Eurasian plates are colliding, and they cause folded mountains. Dome mountains are nearly circular folded mountains that result from uplifting. And typically, dome mountains are singular features. They occur by themselves. Volcanic activity can form mountains and mountain chains. Fault block mountains, horsts, and grabens are associated with normal faults. And again, remember that in this case, the rock masses are moving apart from each other. Here you'll see that it's being stretched. We don't have compression, we have stretching. This rock mass moves in this direction, this one moves in this direction. These rock masses fall, and the middle part remains at the same level and calls what we call a horst. A graben is just the opposite. Again, we have stretching, but the two outer blocks remain at the same level, and the middle block is the one that would sink in a graben. Folded mountains. Mountains formed when two plates carrying continental crust collide, folding the rocks and earth with great force. A dome mountain, again, a nearly circular folded mountain and usually a lone feature. They occur by themselves. Fault block mountains, mountains formed from blocks of crust that have been faulted and tilted at the same time. This is a conclusion of the Chapter 11 lecture notes.